All right, class. So I'm going to do 2.2 separable equations. You can see this highlighted part here. All right, make sure that you review your integration rules, which I'll kind of go over as I do a couple examples today. Like especially the U sub, you want to be able to do U substitution and integration by parts, okay? All right, so now separable equations is going to look like you'll have your derivative equal g of x times h of x. So it's the product of a function of x with a function of y. Now the reason for that is, right, it allows us to separate and integrate to find a solution for the differential. Whoops. Okay, so here, if you think about it, if I can rearrange and dy over h of y, right, and I write it as gx dx, right, you could see we are then able to integrate both sides. So the idea is separate and integrate. Okay, cool. All right, so let me show you an example of, and this is a little bit tricky and just going over some exponential rules, right? So say you have this equation here, okay, and you want to know, can you separate, is this separable, right? And so think about, you'll see this quite a bit, exponent rules here, right? So if you're adding, you can if you're adding exponents, really like multiplication, right? So it looks like this, right? I could break it up like that because same bases, you could add the exponent. So you could see that step could be a little review for you guys. Now, if I group, and you don't have to do all these steps if you notice it right away, but say I group the x's together and group the y's together, right? You could see that here you have a function of x, or let's call it g of x. And here you have a function of y, so let's say h of y. All right, and so this is separable. Okay, and again, the reason why it is, you could group x's together and group y's like this. Okay, and then you could integrate as it goes along. All right, so that's an example of something to be separable. Let's show an example of non-separable, right? So here you have dy dx. Notice the difference. Plus sign. We cannot separate that, okay? You cannot group dx with just sine x. So this is non-separable. Okay, all right, let's do our first example. And what we want to do is, can we find solutions? So this is one method. You'll see in chapter 2, there's quite a bit of methods. So one is separate if possible. If you can't separate, you can't solve. Okay, so let's look at an equation given to you this way. And we want to be able to separate and integrate, or check to see if we can separate, right? So think about, let's divide everything by, remember, because we want it to get to look like dy over dx, right? We want that look to be a function of x times a function of y, if we could do that, right? Or get it to look something like this. And then we know we could integrate from there. So what I want to do is let's divide by dx. And let's also divide by 1 plus x. All right, so now you do have it. And I know I'm giving quite a bit of steps. You don't have to take all these steps, but if it's easier to get it into that form and now we could separate it, that could be a little bit easier for you guys. I don't know. I might have done a couple steps real quickly and maybe just got to this where it was dy over y. So now I'm grouping. All right, I'm separating the y, putting that with dy, and dx over 1 plus x. Basically just flip-flopping right here, the y and the dx. So like cross-multiplying type operation. You know, I might just go right to here, which is fine. If you guys can see that right away, I would prefer you do that as quickly as possible. But if you need to see the steps and it's safer and you want to get questions right, especially on a test, you might want to go through and just make sure you're doing this correctly. Okay, so once you separate, right, so here we separate, and now let's integrate. Okay, so if we integrate here, remember 1 over y is going to be ln absolute value of y. And then again, here you have another function with ln, so it's ln absolute value of 1 plus x, and then plus c. Okay, with this here, I'm going to make this c1 and c2. But just thinking about this, you don't always have to do this. Usually I keep my constant on the x side, because if I'm subtracting two constants, it's still constant. Okay, so here I'll get ln absolute value of y equals ln 1 plus x, and then I'm going to write this as still plus a big C. And you can see, like, usually I skip this step because I don't put that C with the y value, because you're always going to get that one big constant anyway. Think about adding any two numbers together, you still get another constant, doesn't matter. Okay, when you're solving ln, right, we know if we use e, so e to that y value, to the ln absolute value of y, and then e to the ln 1 plus x plus c, right? So a couple properties here, e and ln are inverses. You get absolute value of y equals, be careful with this, okay? You want to break it up, e ln 1 plus x, and then e to the c. Now, e to the c. So think of e to the second, e to the third, e to the fourth. Still constant. So again, what we could do is c comes out, use your properties of logarithms, you get 1 plus x, like that. So basically what we have is when you solve, okay, you could solve it as y equals plus or minus c 1 plus x. But when you're solving, really the plus or minus doesn't mean too much, okay? So this is our solution to our differential that we started with up here, okay? So and there you go.